Okay, in this new video, we will be entering into a new chapter which is on alcohols and phenols. So, what are the course outcome for this chapter? Again, is similar to what we have seen in chapter 1 and chapter 2, right? So, it's to identify, which is to name or to draw, predict and synthesis of various organic compounds and chemical reactions, and also including of analytical chemistry, chemical mathematics, or gravimetric analysis, assign on perform activities pertaining to the application of organic and analytical chemistry in daily life. So the course learning outcome for this chapter would be to name the alcohols, okay, and also to explain the physical properties of alcohols and phenols, for example, on the solubility and their boiling points. Next is to write or predict, right, the synthesis, reaction, preparation of alcohols and phenols. Analyze the reaction of alcohols and phenols, example, halogenation, carbonation, esterification, oxidation, addition, and reduction. So the syllabus contains 5 subtopics again, which is firstly on the alcohol structure, and then nomenclature is on the naming of the alcohol according to the IUPAC rule. Third would be on the physical properties of alcohol. Synthesis of alcohol, how we're going to synthesize alcohols and phenols, and also reactions, okay, reactions of alcohol, okay, which also includes sulfonation, halogenation, nitrosation, and carbonation. Okay, so for this first part, we will talk on the structure of alcohol. So alcohol, aliphatic alcohol, is a derivative of alkane. It's a derivative of alkane in which one of the hydrogen atoms is replaced by a hydroxyl group. So, for example, in an alkane, so this is an ethane. So normally, if it's an ethane, all of it will be filled with hydrogen. But now, now we will replace one of the hydrogens with an OH. Okay, so pay attention to the new structure. Okay, so everything remains the same on the other parts, okay, except for this particular hydrogen where we replace it with an OH. So when we replace in an OH, initially this was an alkane, now we are going into alcohol. So we call it alcohol because the presence of a hydroxyl group, okay, attached to the carbon chain, okay, the hydrocarbon chain. Okay, so this part will be the hydrocarbon chain, this will be the alcohol group. Okay, so hydrocarbon chain and then alcohol group. Right, so the general formula, okay, general formula is this. So examples of alcohol, we have the methanol, the ethanol, and propanol. Okay, so ethanol can be used, ethanol is the most commonly used, okay. It is used for solvents, okay. It's also in your alcoholic drinks, for those drinks. It is also fuel for vehicles. Yes, your fuel of vehicle does contain some alcohols. Okay, and also to make ethanoic acid for preserving food and also making esters. So another alcohol that is very unique is the phenol. Okay, phenol. So phenol is very special. So phenol, why is phenol special? Because this is actually a derivative of benzene. So as you know, our simple benzene ring is this. Okay, so we add the hydroxyl group, it becomes a phenol. Okay, even though this is called a benzene, alright, after adding the alcohol group here, then there's no such thing as changing it to benzenol. Okay, no such thing. So please be aware that the special name is called phenol. Alright, so in other words, phenols are hydroxy compound with the hydroxyl group attached directly to the benzene ring. Okay, so here we have the p-cresol or paramethyl phenol. Okay, paramethyl phenol. You have this part is the phenol. Alright, this is a methyl. Okay, so this is when it is methanol, and then the benzene ring now is a substituent called phenol. Please be very aware, because this is when the benzene ring is attached to the carbon. Only if when the OH group is attached directly to the benzene do we call it a phenol. Okay, so please be very careful. So alcohols have classifications. They fall into different classes depending on the OH group's position, so on the chain of carbon atoms. So there are some chemical differences between the various types. So basically, for alcohols, we have three different classifications for them. We have the primary, secondary, and tertiary. Why is it important to identify whether it's primary, secondary, or tertiary? It will affect greatly on the chemical reactions later on. Okay, so how do we identify primary alcohol? The carbon that has the OH has one hydrocarbon chain attached to it. For secondary, the carbon that has the OH has two secondary two hydrocarbon chains, okay, attached to it. So again, carbon with the hydroxyl group attached to it. If there are three hydrocarbon chains around it, this is a tertiary alcohol. Okay, so this is another slide to show you on the differences between primary, secondary, and tertiary alcohols. Okay, very important to know how to identify them, because they undergo different types of reactions. Okay, in other words, they can use the same reagents, but the products that they get may differ. The products may differ based on the class of alcohols that is used as the reactant. Okay, so in alcohol is also a form of an isomer. It can be an isomer. So in this case, we have C4H10. Okay, if it is a straight chain, we would identify it as a butanol. As a butanol or a butane 1-ol. Okay, butane 1-ol. Alright, so similar to alkyne, they can be isomers. I hope you still remember what are isomers. So the isomers are basically substance with same chemical compound, okay, but different structural, differ in structure. Okay, so in this case we have the butanol. Okay, an isomer of butanol is the butane 2-ol. Okay, another one is 2-methyl propan 1-ol. Another one is 2-methyl propan 2-ol. So here, isomers of butanol, we have covers the three different classes of alcohol. Okay, if we're talking about butanol and 2-methyl propan 1-ol, these are primary. Okay, butane 2-ol is secondary. Okay, how do you know it's secondary? Look at this carbon. Alright, the carbon that has the OH attached to it. Alright, and it has one carbon here, another carbon chain here. So this makes it secondary. Okay, so this one, for the 2-methyl propanol, this is the one that we're going to look at. So since there's only one branching out here, okay, so this is actually a primary alcohol again. Okay, now for the 2-methyl propan 2-ol, when we look at this carbon, okay, and then you have 1, 2, 3 hydrocarbon around that carbon, then this is a tertiary alcohol. Okay, so that is all for 3.1, where we talk about the structure of alcohol. Now we go into nomenclature of alcohol, so also known as naming. Okay, naming the alcohol, right? Following the alcohol. So what are the rules to follow when giving IUPAC names? First, it's similar to what we have done in alkane, alkyne, and then we have the benzene and also the carbonyl. Alright, first of all, we have to find the longest chain, but now the longest chain must contain the OH group. So in this case, we have to look for this carbon attached to form the longest chain. So here is highlighted to you already. This is the longest chain. Alright. And then we have step 2. Parent name of alcohol is named by replacing the suffix E in the name of the alkane with ol. So initially we have methane if it's an alkane. So okay, let's just add another one here. Okay, methane now becomes methanol. And then we have the ethane. Ethane now becomes ethanol. And then we have propane. Now is propanol. And then butane. We have butanol. Pentane for pentanol. Hexane for hexanol. Heptanol. Okay, heptane. Heptane. Okay, heptane now becomes heptanol, and then octane now becomes octanol. Alright, so this is how the name change from the alkane. So the last letter, which is E, now we replace it with OL, so it becomes an alcohol. Step 3, you have to number the alcohol. Okay, carbon atoms to give the carbon atom bearing the OH group the lowest position. So here what's important is, okay, now that we have the OH group, right? So we have to give the carbon atom that has the OH group the lowest possible position. It needs to be the lowest possible position. The position number is written in front of the parent's name, separated by a hyphen. Okay, so for example, we look at 2-methyl-propanol. Okay, so automatically where the OH is, this would be carbon 1. So if this is carbon 1, 2, this is carbon 3. Okay, or if you want to go up also can. Alright, but the methyl will still be a carbon 2 and then 1 propanol. Okay, here another one, we have 2-methyl 2-propanol. Okay, again we look at this. Alright, find the longest chain. So the longest chain would be 3 carbon, 3 carbon, 3 carbon, right? And then let's look at the next one. We have the 4 carbon. This is butanol, but now our OH is on the 2nd carbon. So starting from the left hand side, alright, will give us carbon number 2 is where hydroxyl is attached. If we were to start from the right hand side, okay, let me change this. So if we start from this side, it will not give you the lowest position. It will give you 3, right? But if you start from the left hand side, it will give you 2. So 2 is smaller than 3. So hence we start from the left. Alright. So in some cases, in some cases you have whereby you have the double bond and then you also have the OH. Okay, so both actually takes the suffix. Suffix means the one at the end. Okay, so pent, maintain. Pent means there's 5 carbon, right? 1, 2, 3, 4, 5, right? Pent, and then in. Okay, we have the in. We have the in, which is the double bond. Okay, the double bond here, the double bond here. will give us the in, and then OH definitely will give us the O. So in this case, we follow this particular rule whereby we find the carbon atom bearing the OH group must be of the lowest position. So that's why we start from the right hand side. So carbon 1, carbon 2, okay, carbon 2, carbon 3, carbon 4, carbon 5. So your double bond will be at carbon 4, your OH will be at carbon 2. Why we don't start from the left hand side? Is because if we start from the left hand side, our carbon number for the carbon bearing the OH group will become the 4th carbon. This is not the smallest or not the lowest position it can give. So okay, so please be very careful with that as well. Okay, you have to be able to identify, right, which one will give you the lowest position. Step 4. The other substituents and the position numbers are arranged in alphabetical order, okay, using commas and hyphens. So this one you know already, we've done it in the previous chapter. Okay, alphabetical order, very common mistake that's always being made. Okay, it's not arranging them in alphabetical order. Okay, please be careful. Step 5. When there are two or more, we have the diol or triol and so on. Each position of the hydroxyl group is written in front of the parent's name separated by comma. So if there are more than one OH, like in this case, you must identify the position for both. Okay, you must write 1, 4. Well, in this particular structure, one can start from here, okay, or if you want to use the other direction, it will still give you the same number. Alright, so but what's important here is that you must state each position where the OH group is written, okay, in front of the parent's name, okay, in front. So please don't write in between. Like for example, here you write cyclohexane 1,4-diol. Okay, please don't use this method. Okay, this is the old method. Okay, now they prefer the new method. Okay, so please don't use this method, not this method. Please use this method. Okay, so alright, so there are also more complex cases whereby the OH group can also be a substituent. So if it's a substituent, it can be it's called a hydroxy. It's called a hydroxy. It's a bit difficult to see. Maybe this is a bit difficult, right? Okay. It also can be known as a hydroxy. So in this particular structure, alright, the carboxylic acid has priority. So because it has priority, it gets the suffix. So now the OH group becomes a substituent known as hydroxy. So it is placed in front. Okay. This one you'll see most common, I think in chapter 4. Chapter 4 you see this, if you have not forgotten, right? Now, again, this example is talking about when you have double bonds and also this. So in this case, both will take the suffix, okay? But of course, OH should give the smaller value or the lowest position compared to the double bond now. So we have some special cases also called the polysubstituted alcohol. Okay, polysubstituted alcohol. Alright. So polysubstituted alcohol means you have more than one OH. Okay, some more complex, considered a bit more complex compound. Okay, so here we have the longest chain is 8 carbon but even though it's 8 carbon, alright, we don't take the longest chain here as 8 carbon. Why? Because we must consider the 2 OH. So even though 8 carbon is the longest chain, okay, but because the chain must consist of both of the OH group, so hence why it is going this way. So here they start from the right hand side because it will give you a smaller alcohol number as compared to if you start from the left hand side. If you start from left hand side, this will end up as 3, 4, 5, 6, 7. So you end up with 3, 7, but this one will give you 2, 6. So 2, 6 is smaller than 3, 7. Hence, why? Okay, the name, okay, is 2,6-octadiol, and the following you have the propyl and then you have the methyl. Okay, so here, so the same goes for the example here. So the highlight here would be this particular box. Okay, this particular box here is just to tell you that diol take precedent over alcohol, not the longest carbon chain. Okay, so the longest carbon chain here, for naming, you may have to make sure that it contains both the hydroxyl compound, hydroxyl group. Alright, that is the longest chain. Even though the longest chain here, you calculate, you can actually find up to 8 carbons, but because in the 8 carbon, we don't include both OH, so it is not acceptable. So you have to find the other longest chain that can accommodate both OH group. Okay, very important. Last but not least, phenol. Okay, phenol, the special case one, right? So as you know, phenol derivative of benzene, and it has a very specific name, phenol, right? So phenol, for example, you have the 2-chlorophenol, 3-nitrophenol. Okay, these are all very specific to phenol. As long as you see a compound with this particular structure where the OH is directly attached to the benzene ring, automatically the name would be phenol. So if it is di-substituted like these examples here, then you can use the auto meta para, or if you're unsure whether you're right or wrong, you can also use 2, 3, 4. So if you use phenol, the term phenol, automatically the carbon that carries the hydroxyl group is carbon 1. So it can be clockwise, anti-clockwise, doesn't matter, but this carbon has to be the carbon number 1. Okay, and then we have another special name also for methyl phenols. So methyl phenols can also be called as cresols. Okay, cresols of course is more of a common name. This is more of a common name. Okay, but IUPAC naming would be 2-methylphenol, 3-methylphenol, 4-methylphenol. Okay, for in this case, you also can use the autocresol and metacresol and paracresol. Okay, only special case like this. So benzene derivatives, okay, with 2. So just now, it is only 1 here. There's only 1 OH attached. So if there is 2 OH group, like this one, then the name now is called benzene diol. Still no such thing as benzenol, but okay, instead of benzenol, it should be phenol. But if there are 2 OH group, then only can you use benzene diol. Okay, benzene diol. So 1, 2 benzene diol, 1, 3 benzene diol, 1, 4 benzene diol. Please don't use auto meta para here. Okay, please don't use this, not suitable. Okay, the ones in the brackets are their common name. Okay, so in certain complex cases where OH group can be considered as substituent. Okay, so like earlier we mentioned for complex alcohols. So now the OH here becomes a hydroxy. Okay, because this group has more priority. This particular group has more priority as compared to the OH now. So the OH now becomes a substituent. So as a substituent, okay, be it in a benzene, be it with phenol, or be it with an straight chain hydrocarbon alcohol, all right, as a substituent, the name here should be hydroxy. Okay, so please take note of that. So these are some tutorial questions. You can try and draw the corresponding compound here. So there are like 1, 2, 3, 4, 5, 6, 7, 8, 9 structures, and then here you can try and name them. Okay, so you can try and do this on your own as to test out your skills. Okay, all right, so we can discuss this later on during our live session as well. Okay, or you can actually request for the answers from me after you're done as well. Okay, so that is all for this video. See you in the next video.